You can start maybe by telling us a bit about yourself and the kind of work you do. Yeah.
Yeah, sure. My name is Frank Sardis. I used to be a researcher at some point in time, a few years back, and I was mainly looking into 5G telecommunications and cloud computing and how those two work together, how you combine the two technologies, and effectively how do you enable use cases that require ultra low latency or ultra reliable communications. And so, in my time as a researcher, I focused a lot in these areas and developed some demonstrators and use cases, and eventually some live demos and some events where we showcased the capabilities. And at the center of it all was OpenStack at the time. So we're looking at what was it, like 2017, 2018, and 2019, those 3 years is when I was kind of really working hands on this technology, and I was responsible for the operations.
Yeah, that sounds really interesting. Uh, I have read a little about the whole 5G, the 5G adoption in the UK. So, how is the adoption looking like right now?
It's growing. It's going well, and now we're looking at 5G advanced, and we're looking at slowly the 6G standardization. Right, we're entering that phase. Although I haven't been keeping up to speed with telecoms, again, my background being mostly on the actual network and the cloud part of it. And then you have all the radio and the network functions and so on that run the radio and run all the subscriber services and so on, which is a completely different part of the picture. But ultimately, the common denominator in all of this is that they have to run somewhere, and typically they will run on some kind of private cloud platform or public cloud platform. And at the time when I was involved in these, OpenStack was sort of the weapon of choice at the time.
Yeah. So, how did you get involved in the? You called it the testbeds and trials program.
Yes, that was a UK funded program. So that was a UK government funded program, and the concept behind it was to build a test bed that will showcase the capabilities of 5G and therefore accelerate the adoption and generate knowledge and hopefully create business opportunities as well. That was the general idea of it. So it was a collaboration between three universities. It was King's College London, which is where I was. We had the University of Bristol and University of Surrey, and then from our side with King's College, we had a collaboration with Ericsson, who provided the prototype 5G equipment for us.
Oh, interesting, interesting. So this began in a very academic setting, if I may call it that.
Yeah, it was strictly research. It was very early days of 5G. Nothing was sort of concluded. All right. And everything we're working with was experimental, pre release. And we also then had our own sort of developments in the lab where we had completely experimental vendor agnostic solutions for things like function splits and testing how you can do function splits on the radio, at what different levels you can do them, and how can you run those on a virtualization platform. And do they work? Do they not work? Because some of them had absolutely insane requirements, let's say, when it comes to latency and jitter, down to microseconds, for instance. So some of them naturally were not really feasible, but some of them that were a bit more kind of relaxed, they could work, right? So it was a matter of finding the sweet spot. And then on top of that, we had all the other supporting technologies, which is how would you do things like video broadcast? How would you transfer data for haptic communication? At some point, we tried VR streaming, we tried robotics, telesurgery, and so on and so forth. So we had various applications running in the cloud to support these use cases. Mainly things that would process data packets and they would instruct robots or machinery or give you haptic feedback and so on, depending on what was happening on the other side. So it was kind of a platform that we used to research both the connectivity itself as well as the technologies that support the use case.
Yeah, that sounds really interesting. So you mentioned distributed concerts and you mentioned latency. Maybe explain to someone who doesn't know what distributed
Yeah.
concerts are and how important was it for you to have, and what was the lowest latency, you could possibly allow?
Okay, so that's a trick question. Let's take it from the right. So the music concerts was one of those kind of let's say events that caught more attention. We did a few of them, in fact, some small scale, some bigger scale. The principle was the same. Some of them were between different countries. The very first one we did was between UK and Germany. Then after that, we did within the UK a couple of locations, and then eventually we had a big one, which was I want to say three locations in the UK. I don't remember exactly where they were. There was one in London, obviously, which where I was stationed. Um, there was one, of course, in Bristol, and I think Birmingham was the third one, which was like the bigger concert we had with this band effectively distributed in different places. So in London, we had a singer pianist performing, and then in the other locations, we'll have the band which had supporting singers, backing vocals, and then drummers, guitars, bass, all sorts of other instruments. So the first challenge is how do you connect all these locations, which, okay, you can get fiber to connect all these locations. Then the question becomes, how do you ensure that the latency is consistent between the locations, right? And then that you sort of tackle with SDN, and you kind of optimize things, which we'll get to a bit later on. And ultimately, to get to your question about the latency. So what really matters was not so much the network latency, as in I'm pinging something, right? Because that's going to return, microseconds, which is fine. But the real challenge was, and that applies to robotics as well, or VR, was the total end-to-end latency. So when you're dealing with audio and video, you have to take into account the latency of encoding and decoding at each end. When it comes down to video, and if it's VR and you're interacting with things, you have to take into account the latency on the monitor itself. Usually, LCD displays and OLED displays and all that, they come with like 8 millisecond latency, or higher, or thereabouts anyway. So you have to account like the total latency, right? And depending on what we were doing, the latency would fluctuate. But for audio, one thing we did is for audio, we wanted consistency in the music events. So the audio latency, including sort of codec, let's say, delays, was about 30 milliseconds, and for the video we were up to the hundreds, 150, or so. And then depending on what resolution we would do, if it was HD or 4K, that could grow to 300, 400 milliseconds. So there was a noticeable kind of difference between the audio and the video. But if you kept it low, as in HD at the time, there wasn't much difference. It wasn't noticeable. So you had very, very good quality of video and very, very good quality of audio, and they were synchronized.
Wow, that's interesting. I can imagine attending a concert with like five locations. The instrumentalists are in a different locations from the background vocalist, from the lead singer, and having one seamless experience. I think that would be really cool to see.
Yeah, I mean, from the audience's perspective, you would have essentially the main singer in front of you. So the way we run it is the venue in London where we had the singer and pianist is where we also had the audience. and then the rest of the musicians were effectively in a studio environment, right? So they were streaming from studios in these locations, and so the audience was just in one place. It wasn't like an audience in different locations that each one would see different band members. But yeah, it's entirely possible if you wanted to do that sort of thing. You could have audience at every location because every location had a video feed and audio feed, so they could hear each other play and see each other as well.
Great. So I'm wondering, what kind of thinking went into this is the kind of tech we need for this, and where does OpenStack play into all of this?
Mm. So the selection of OpenStack came long before any of this. I was running different projects at the time. One of them had to do with virtualization and software-defined networks for energy, renewable energy, and it had to do with how do you guarantee reliability, how do you guarantee quality of service. So from early on, I had sort of settled on the usual kind of, we had Linux in the lab, and then OpenStack sort of became a natural choice at the time, mainly because our partners were also kind of working on OpenStack, and everyone was familiar on the platform. So it was the natural choice there. Now, from there on, yeah, we already had that, but once we got into the 5G testbeds and trials program, we took everything we had in the lab, we threw it out, we brought in entirely new equipment, much more high performance equipment in terms of servers, CPUs, and memories we had, and disks we had, and so on. And at some point, if I remember correctly, like that small data center we had was, it had like over 2 terabytes of memory across the nodes and over 2,500 cores in total. So it was a decently sized, um, let's say, edge cloud, if you will, or on-prem cloud. And essentially, that's the backstory of it, because the idea, when once we got into the 5G testbeds and trials, was that we knew we have to go for really high performance. We knew that we had some events coming up and we needed demonstrators, and we had to go outside the lab effectively, right? So the entire design started from pretty much down to the basics of what fiber do we need, right? Just reinstall fiber, bring all the new equipment in, the data center, what cooling do we need for the data center, what power do we need for the data center, like from the ground up design. And it all had to happen within 7 months is all we had. So all the equipment came in, and then again, what would you choose there? Well, we were familiar with OpenStack already, so my choice was let's do OpenStack again. And we knew that OpenStack is not going to be a problem from previous experience with testing in other projects, but also because largely when it comes to performance of these functions that we're hosting in OpenStack, it's not OpenStack itself that deals with it. It's all the networking and the underlying hardware that need to perform, and the OpenStack is there as the middle layer to manage the VMs and deploy things or destroy things when you don't need them anymore. And so, yeah, it was the natural choice, as I said before.
Yeah, that sounds interesting. Sounds like it was an easy sell to the rest of the team.
Yeah, it had all the features we needed. In fact, it has more features than we ever needed. And towards the end of the testbed's life, I started implementing more and more things as well in OpenStack. So at some point, we were able to have live migrations of virtual machines between nodes for failover purposes. But then I was able to combine that with other things. Again, being a research setting, we were able to demonstrate that you could move a VM from one node to another based on a specific user's location. And if that node was attached to a location and a user moved to another location, then that VM that belonged to that user could move to a node that is closer to their location, still managed by OpenStack. And at some point, I even had one of the OpenStack nodes running at my place at home over VPN. So when I would come at home, I could just move a VM over the internet to my home computer. But yeah, that was just an experimental setup.
Wow, that sounds incredibly complex, but so much fun to implement.
Yeah.
Yeah, I know OpenStack has a lot of services. You know, there's a whole loads networking, compute. What were the main services that you worked with the most?
Oh, the core ones, right? So we'd have like you can't avoid Keystone. You need that for identity, right? Then you had all the usual Neutron, Nova, for the scheduling of the VMs, the networking, the storage one, which I forget what it is called now. And
There are
then I have
several. There are several for storage.
we have we have we had Glance obviously again for the images to deploy the VMs, and I had Horizon as well just to have a pretty go and not type all the time in the terminal. And that was it. That was the core services. Really, it was a very lean deployment. A lot of the optimization was again the underlying hardware like BIOS configurations, Linux kernel configuration as well. Had to do with things like huge pages, CPU, like core isolation, things like that. Which again I can go into detail if you want.
Yeah, I think that's fine. I would imagine the OpenStack community knows the different services that they use. Yeah. So I'm wondering, as you are setting up all this hardware and managing it with OpenStack and just trying out all these things. One of the other things that you mentioned was telesurgery. That
Yeah.
sounds very risky. There's life involved. So, what were some of the failover or recovery options that you thought about as you were
Yeah.
working on
Okay.
that?
Yeah. So we didn't try it on anything alive. When we were experimenting with it, we were experimenting with robots developed by PhD students in the medical school. So they would provide. I don't remember what they were called, but they were kind of. It was like a snake. It was effectively a catheter that could move. It was very flexible. And so we were controlling these with various devices. We could control it effectively if we wanted with a keyboard and give it instructions of where to go. Eventually, what we did is we had haptic gloves, some prototype haptic gloves that we procured, and then we were able to use the haptic gloves with hand gestures, control the robot. And then the great advantage of it is one of our PhD students at the time developed a solution where if the robot found an obstacle or if the robot detected an anomaly, you would receive vibrations in your fingers to indicate that there's an obstacle there or there's something that shouldn't be there. The idea behind it being like a catheter, this soft robot, was that it would go inside your body and sort of like in a minimally invasive way feel, let's say, your kidney and see if there's a tumor there, right? So as it passed over the tissue, if there was a tumor there, it was slightly harder, it would then transmit that back to your finger so you could sense that there's something there, right? And that was the idea of it. So we had various ways of sort of detecting that. We had like a sample of a silicone implant that we put a plastic bead inside, and then the robot would go over it and detect if the bead is there or not, and would transmit it to our fingers. Then we could use our fingers to move it around. So in all that, so on one side, if you can imagine, we had a doctor, let's say, right, the operator, where we would wear the gloves and had the laptop, and that would connect to the infrastructure. It would transmit oral gestures and all the packet data effectively going into the cloud, into OpenStack, where we had the VM process the data and then send it to the other side to the robot, where the robot would then translate those motions into those gestures into actual movement and where it needed to go, and then in turn would transmit back data to us so that we can feel if there's an obstacle or anything else.
Wow. So you had to work with the actual doctors who are PhD students at the time.
Yeah, yeah.
Oh, that sounds interesting. So I feel like what you guys did with the team was we know OpenStack. Let's push it and see how far we can push it. Were there any surprises? As you implemented, you're like, oh, we didn't know this could happen. We didn't know this kind of capacity was there.
Oh yeah. I mean, it at multiple layers, right? And there were kind of human errors. 99% of the time, it was human errors in the sense that um, there would be a typo in the configuration file somewhere that when you type it, you don't notice it, and then you go there. And initially, it looks fine, and then you start deploying things, and errors all over the place. Why did this happen? How? So you go into the error logs, you're trying to figure out what it is. Then you go to your settings, like, ah, there it is. There's a typo there. That's what triggered it. So you had mistakes like that. Then you had more serious design mistakes. So initially, and because of the time constraints, I approached it in a very kind of naive manner. So the network was very simplistic. It was just kind of a flat topology, everything essentially in the same broadcast domain. Well, turns out not a great idea, right? So when you're going for high performance, you want to isolate traffic as much as possible. You want to start implementing traffic control rules with SDN controllers. So eventually, I had to rebuild the entire network, and we had dedicated physical networks for all the open overlay networks for Neutron. Then we had dedicated physical networks for SSH and management of the nodes. So none of that traffic is going to be on the actual network with the user data, right? And then we had things like the APIs for OpenStack for management, various other things that, again, they would go into their own independent networks. And everything was 40 gigabit. Some of the networks that didn't need it, they could be gigabit. Some of them could be 10 gigabit. In terms of redundancy, everything was all the links were kind of aggregated, so we could have failures, two links at minimum, sometimes four links paired together, and in some cases, we also had redundant paths as well. So if a whole switch would go down, then there was an alternative path that we could use. But thankfully, we never had to go into that sort of failure mode.
It's interesting. So there's a joke that the human is always the weakest part of every system.
Yes.
Yeah.
Yeah.
So what would you do differently if you were to do this again?
If we're talking specifically about the OpenStack deployment, I would most certainly take the time in the beginning to design it properly, because we're sort of 2 months into the project when I realized that I need to redesign this network and make it a bit more, let's say, professional, a bit more serious for this kind of use cases, right? And especially this became apparent, especially when our partners started bringing in their equipment that needed to attach to the test bed, and then you had all the prototype equipment, you had experimental equipment, even you had other people coming in who wanted to try use cases. And if everything was just flat, right? So there was a risk of security as well. Why would you have everything flat where everything can access everything, right? And everything can talk to each other if they wanted. So we started isolating things at the time, and being more careful, but also then kind of having that fine grained segmentation so that we can control the traffic more effectively. And I would definitely save myself a lot of stress if I had done it properly from the beginning. So that's the main thing, I would say. The other one would be I'd probably like to get more, let's say, coding, involved in coding, because um, during the the entire program, my role was design the testbed, build the testbed, make sure the testbed runs, then help everyone bring their stuff in and make it run. Okay, and a lot of the time, because I knew the capabilities of the testbed, I knew also what people wanted, and I was trying to bridge the gap if there was a gap. But that effectively meant that I wasn't there participating with the development of the applications, right? So I didn't write any code for the robots. I was sitting with the people doing these things, and they would tell me, "I need lower latency here. Can we optimize that?" and so on. At which point, you start looking at what's happening on the network, what's the traffic like, how many packets per second, so on and so forth, and you start looking at window sizes, you're looking at frame sizes, you're looking, MTUs and all these things, and you're trying to optimize it at that point, to make the use case work really, as best as it can. And then the other thing that's interesting about, of course, many use cases had contradicting requirements. Like video seemed to work very well if we could have a large MTU, so a whole frame could fit in one packet and send it out. But then other use cases wanted smaller packets, just to maintain that low latency and keep sending packets, right? So we had that that challenge as well, and there was a bit of reconfiguring things. Then we had, I remember one big surprise was a few days before one of the big demo events. I don't remember which one it was because we ran several, but we connected to the testbeds with our partners, Bristol and Surrey. Nothing was communicating, and the reason for that is because I had set my MTU to something like 8,000. I was using jumbo frames, particularly because I was testing video, and then everyone else wasn't. So immediately, that was a problem, and we're just scratching our heads. What is going on here? Why is this happening? Then I realized, okay, well, wrong MTU sizes. And then once you get to that, that means now, change everything in VMs, opens the hosts, the nodes, and the switches, everything, all the interface. So that was okay. Now let's go back manually, change everything. So not fun, but still quite an experience.
So I'm trying to understand why you said coding would have been important. Would it have helped with like automating? Like if you're making a change, like the MTU change, you just make it in one place, not 10 or 15.
That was definitely one aspect of it. The other aspect of it was infrastructure as code, which I started doing again later on towards the end of life of the testbed. I started using Heat a lot more to automate the deployment of virtual machines, because we had, it was rarely just one VM to be deployed. It was usually a bundle of virtual machines that had to be deployed, and each one was doing a specific function. Sometimes we wanted to deploy a whole cluster of virtual machines that would host Kubernetes, and then we'd have containers, right? And initially, during the time constraint, like because of the time constraint, during the early life of the testbed, all that was done manually because it was a one-off thing, but also because the requirements came in and somebody told you, you need to have that ready in a few days, around the first test. You just wanted to start deploying as quickly as possible, get it up, and then ask people to test it, see if it works, and then go back and make adjustments as required, to help everyone. Oftentimes, yeah, I would work with developers. I would work with people that did the robot programming. I would work with people that did the function splits for 5G VNFs. But yeah, I wasn't the one writing the code for the most part. I wrote code for my sort of own pet project on the side, which was a little robot. It was a little rover robot where I had all the AI, all the intelligence running on OpenStack in the cloud, and then the robot was simply sending signals and receiving instructions from the AI running in the cloud. And then we were able to play with the latencies and the bandwidth to see how those would affect the performance of the robot, um, as it was operating. And you would see things, for instance, if the robot goes slowly and you have a high latency, so when it received the signal that there's an obstacle, right, it would transmit that signal back to OpenStack where we had the VM to process that signal and basically tell it to stop so it doesn't crash. So if it was moving slowly and you had a high latency, it would transmit the signal. The latency was high, sure, but by the time it got to the cloud, got processed, and then sent back to the robot, you had sufficient time to actually make it stop. But if you still had that high latency and the robot was traveling really, really quickly, by the time it got the signal from OpenStack to tell it to stop, it would have already crashed because it would have covered much, longer distance at the time. So there was this kind of correlation between the speed of the movement and the latency. And we did a demo as well eventually where I was able, depending on the speed that you would tell the robot to move, it would also send a signal to the SDN controllers to prioritize the traffic accordingly to ensure that no packets are lost or we get lower latency, especially if there is other traffic on the network that could conflict and kind of contend for resources.
So, what I'm hearing you say is when you're designing, especially complex architectures, you'd rather spend some time doing, designing for scale, even if you're not there yet. But on the other hand, there's the issue of time. You had 7 months. You couldn't spend 3 months just, we're designing, we're designing for scale. So how would you work that balance if you were to do it again today?
It's again, it's going to be dictated by the timeline and the sort of budget and number of people you have and how quickly does it need to be delivered, how complex is it, what is the future plan for it, is it a long-term thing, is it a one-off thing, right? There is no point in building something to scale if you know that it's only going to be within that you know uh, very specific use case, and then it's going to be discarded and repurposed for something else. So you need to choose your battles. But if you do know that there's a long-term plan for whatever it is you're building, then I would say measure twice, cut once, right? Take the time. And even if, and this is important trade-off basically, but a very important decision, even if you have this time constraint where somebody may tell you, well, you need to have, let's say, the prototype, the very basic thing running in 3 4 months, 6 months, whatever, right? Then you're thinking, okay, I'm in a hurry, I need to do it as quickly as possible, maybe I need to cut corners, and then that sacrifices some of the long term, because then once you get out of that, you have to go back and say, well, okay, the prototype works, but it wasn't really designed for scale, now I have to redesign everything. So you have to choose your battles there very carefully and say that, you know what, okay, maybe it is 7 8 months, but I think it's worth taking the time now to get it right. And if you can extend it, like if you can meet the deadline, maybe you can try to extend it. If you cannot extend it, then choose specifically what design you want to have in place. And even if it's not necessarily a perfect design, then at least get the core components in place. So, for instance, in my case, I could have easily done uh, a proper segmentation of the network, proper design of the network, and then still bring in all the nodes and all the experimental equipment and attach it like in a flat way. But then all I had to do was redesign, sorry, no, reattach it to different places on the network and redo the routing. But the way I started, everything was flat by design at the hardware level, right, in terms of connectivity. So there was nowhere I could go. So this is one mistake you can make, right? And then you say, okay, well, maybe design the network properly, but don't worry so much about, where everything attaches for now. Get it running, and then once you go through that first phase, the 7 8 months, the proof of concept that everything is there, then unplug everything and then put it in the right places. But at least you will have the foundation there in terms of design, and everything will be waiting, in the right place to be connected.
So it's a trade-off of time, of resources, and let's just get this working. Then once it works, we have proved the concepts, then we can think about scale.
Yeah.
Interesting. I've also heard you talk about when you thought about latency within like a video streaming context vis-a-vis a different context. So does it mean that latency is more of a use case thing? It's not a one size fits all kind of thing.
Absolutely. Oh, yeah, absolutely. So, a very good example of that is when we're experimenting with cloud gaming, effectively streaming games from OpenStack. We had some nodes that had GPU, so we were able to stream video games. And you have slow video games like strategy video games, and then you have very fast-paced video games, so racing games, shooting games, that sort of thing. And the latency is vastly different, right? One can survive in terms of like streaming the images, one can survive with 30 milliseconds, the other one doesn't. It needs like 10, 15, for example, right? And once you start bringing VR into the mix, then it's not so much about the interaction of the player with the game, it's also the human factor and the way our brain works. Because if you move your head around, but then the VR image is slow to react, you will start feeling sick. You get nausea, right? So that becomes then kind of a hard requirement, and it doesn't depend on anything. It doesn't depend if whether or not you're playing a slow game or a fast game in VR. It's more of a I need it to run, otherwise people will not feel well. The user experience will be terrible anyway. So yeah.
Wow. Yeah. So I'm wondering, after all this work that you did with the testbed trials, are there actual companies or businesses or organizations that you can point to and say, yeah, this is the direct result of the work that we did?
A direct result of the work we did there. I mean, I'm aware that there is something happening with um, telesurgery. Um, it's been developing for a few years, but again, I have been out of the game since 2018 now. No, sorry, I'm lying. 2019, end of 2019. So I haven't really followed up on the research and all the latest developments, but I am aware there is something happening with telesurgery and it's being explored in the bigger context of 5G and how, like, to go back to one of your earlier questions, how do you provide reliable connectivity if a link goes down, right? So you can have 5G as the failover link, and 5G can give you, depending on the setting, but it can give you very low latency as well. And that's how we did these events as well with the distributed music concerts and the robotics. The 5G connectivity was able to provide low latency for it, with like when we because we had access to 4G as well, and with 4G it wasn't even close. It was almost double the latency, right? Having said that, it was also a matter of how do you optimize 5G for it. So if you try to do the same thing with just your standard public 5G connectivity now, it's not going to work. You need to actually change the schedulers on the radio and make sure you get the right traffic prioritization and so on. The network slicing is another term that people are talking about, and it's part of this story, right? So I know this is happening with sort of telesurgery, and then from there on the telecom side, the direction the industry is going now with edge clouds and virtualizing the network functions. This has happened already with 5G, but now the talk of having AI, for instance, and AI agents at the edge to manage the radio functions, all these will have an underlying cloud platform, and it's effectively like the edge clouds would be OpenStack or Kubernetes or a combination of sorts. Any other work now that comes to mind? I mean, there's talk. I know there is talk about autonomous vehicles, right? And again, you have this sort of vehicle to infrastructure connectivity where you would have edge clouds and the vehicles in an area, self-driving vehicles in the area, would be able to share information with each other via the infrastructure, via that edge cloud, and that edge cloud could actually send emergency messages or instructions that there's a blockage here or avoid an obstacle coming up ahead and so on. So you have use cases like that. But it's a world of opportunities out there when it comes to edge cloud and its applications.
Okay, so I've been seeing a lot of people talking about the de facto tech stack for for OpenStack is really Linux, Kubernetes, and OpenStack. What would you have to say about that?
Yes, I mean it's what I did. It's what I did as well. And one of the interesting things that I wasn't really able to take advantage of at the time is the standard way of using everything I described. The standard way of deploying things was we had OpenStack deployed, and I basically deployed all the OpenStack components manually at the time. So just you know, all the installation of packages, configuration, everything was done manually. And then we would have Kubernetes running in VMs as needed in OpenStack. But then later on, you were able to deploy OpenStack using Kubernetes. So it would be Kubernetes on the bare metal to deploy OpenStack components. That I didn't get a chance to play with, but I think that is great because you can do so many things and it can improve the reliability of OpenStack components as well. It has a lot of advantages. So I totally agree. I think they complement each other. There's kind of a tendency now where people go straight to Kubernetes and they use it as sort of their infrastructure manager and they deploy applications. But OpenStack brings you that infrastructure as a service kind of functionality that Kubernetes does not natively have. And it gives you the isolation at the kernel level as well if you want to, and not if you want to. It's part of the design, but yeah, if you need it, it's there. So this is normally how I would do things as well, unless I know there is a very specific kind of use case where I don't need infrastructure as service and I can just go bare metal Kubernetes.
Yeah, so right now AI is making everyone worried. It's coming for our jobs, and we're trying to analyze what will I be doing the next 5 years. For a professional with the kind of skill set that you have, networking, Kubernetes, OpenStack, are you worried? Are you worried about AI?
Worried about AI. I'm optimistic, very, very optimistic about AI. I like some of the things that I'm seeing. Um, on the social impact front, um, there are concerns, very, very understandable concerns, very justified concerns as well, um, because essentially it can behave as an assistant, it can function as an assistant that everyone has, and therefore now you need fewer hands on deck, let's say, to do a given task. So I totally understand that. On the technology side, in terms of what it can do for technology. And again, the use cases go from AI to manage the network, self healing of networks, and so on and so forth. So the opportunities are absolutely endless there, and they can have a massive impact if you have this sort of self healing networks, self managed networks. One other thing that I personally like is the intent based networking that you can do. So you can with SDN, and it was a thing before AI, but you could just give it an intent and say, I want high quality of service between, this application and that backend service. And then the SDN controller would compile everything and figure out what's the best path and everything, right? So now you can have an AI in the loop to figure that out. So you don't need to kind of hard code it in the old fashioned kind of symbolic AI as we would. You can have the you know a generative model there or some sort of machine learning there that will figure out how to do things, but it needs to be supervised.
If you were to advise your younger self, what would you tell them?
Oh, that's a good one. More programming, mainly because I got to the point where the networks basically became software defined. So the old-fashioned network engineer was less relevant, and it was more about your programming skills, because now you could go in and start programming the SDN controller to do various things, and programming skills become very, very useful there, because knowing, the network stack and how everything works is one thing, but then if you cannot program an SDN controller, you have to rely on someone else to do it, which is what I was doing a lot of the time, as well. But yeah, it would have been great if I had more hands-on programming, uh, for, like, a lot of these things, and not only just for the use cases, but on the SDN controllers and so on, all the other supporting technologies we had. And therefore, I would say, get a bit more into programming, even if you're considering yourself to be a sort of network and infrastructure person. um, Programming skills are sort of mandatory at this point. It's not just for infrastructure as code, which is basically configuration files, but it's because the underlying infrastructure now, things like OpenStack, things like SDN controllers. If you want to get to that low level of building things, right, then you need to have that programming skill, or you need to find good programmers and then tell them exactly what to do, right? For me, it was a good experience. I would have loved a bit more hands-on involvement with coding, and I would definitely advise myself earlier on to just get a little bit deeper into programming.
Yeah, that's an interesting perspective. Yeah, that's a really, really interesting perspective. So, yeah, so maybe the last question, it's not a question, just a comment. If people wanted to, follow you or, learn more about the test beds and your work with OpenStack, where should they talk to you?
LinkedIn, it's everything is there. That's the main hub.
Has to be LinkedIn.
Yeah, it's everything on LinkedIn.
Ah, great. Sounds like you had a very interesting experience with the test beds, OpenStack, just building out the network. Yeah, so thank you so much for taking the time to come and share your experience and hopefully show the world and other people who are starting now that you can actually build real world things with OpenStack and with open source technologies. Of course, we know we run on open source, but you kind of leave it in the background. Yeah, so it is really really interesting to learn about all the things that you worked in, and yeah, so I hope this will be something valuable that people will find valuable.
Hopefully, yeah.
All right then. I don't know if there's anything from your end.
No, no, nothing to add. Like I said, I've been out of the game for the past few years, but I do keep an eye whenever I can on OpenStack, and I see it has progressed so much more, and so many things have changed. And I believe now it's going to be an even easier thing to get into, and simpler, let's say, but also more powerful, have more features and more functionality. So, uh, I would, if anyone wants to learn how a cloud actually works and what's happening in the background, how do things communicate, how, a VM gets created, how the configuration is passed to the VM, how the overlay network's working, how's the routing done. I mean, OpenStack is going to give you full access to all that knowledge. If you spend time with it and you learn how it works, then you start learning a lot about how clouds work in general.
Yeah, that's true. That's true. I'm curious. Did you ever contribute to OpenStack?
You mean code? No, no, no. We did not contribute code to OpenStack. We did, however, make minor changes here and there. Simple things like if you wanted to have some additional information from the CLI, then we would go and add a few lines of code that would, when you run the command, it would also give you something additional. This is something that a lot of people did, a lot of vendors did that use OpenStack or generally any other open source platform. You'll see that they kind of extend the functionality with their own functions. So um, maybe if you get the vanilla open source version of OpenStack and you type a command, you're going to get a certain output. But then if you get a vendor specific, let's say version, they type the same command, they're going to get additional information that you don't, and that's basically modifying a little bit the code, to make the appropriate calls in the APIs to give you additional information. So very light modifications of that sort, but we didn't go deep in the sense of, let's write a new scheduler or anything like that.
Great. So you did get to extend the functionality.
Yeah, just I wouldn't even call it that, but yeah, if you wish to, if you wish to call it that.
Okay. Yeah, so it's been really, really great to learn from your experience, and I hope that more people will also learn and try OpenStack out and use it even in their real world use cases.
Yeah, absolutely. It's a
All
great
right.
alternative to many kind of on-prem solutions. So it's definitely a good candidate for on-prem solutions if you want your own private cloud. So highly recommend it. Yeah.
Awesome. So, just one thing that came to mind just before we finish, the whole cloud repatriation movement. What's your thoughts on it?
Uh, in my experience, it depends on what you do, right? So what I mean by that, there is definitely cases where you have the performance requirements, the scale requirements, right, the operational requirements to be, to be using a public cloud. But then there are cases where you're better off running your own kind of sovereign cloud on-prem and have complete independence. And it could be cheaper as well, depending on what you're doing, right? If I want to be training, machine learning, and I have the space and I have already the infrastructure, maybe, if I don't have the infrastructure, maybe over the time that I'm going to be running the simulations or machine learning training models and so on and so forth, maybe the cloud cost would justify me just buying the equipment and doing it independently, right? So it's not. It's a question where basically the answer depends on what what you're actually doing, and I mean there's a whole like the whole concept of FinOps behind it, which is like money wise, is it like how do I reduce my cloud costs? How do I make intelligent decisions about how I deploy things in the cloud? And then at some point, you sort of ask yourself the question of, should I be in the cloud or should I be on prem and independent based on what I'm doing and based on, the costs and any other. There's regulatory as well. There's a lot of factors, right? So yeah, I don't think there is a good answer that captures the details of it. But yes, a lot of people do realize that maybe we're better off on prem.
Okay, then. So, thank you so much for sharing your experience.
Thank you. Very good to
Yeah,
meet
thank you
you.
so much.
Yeah.
Thank you
Okay, I
so
guess.
much, Frank.
Take care. Bye bye.
Okay, bye.